All right, min stack. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the min stack class. Um, push an element onto the stack. Pop removes an element from the top of the stack. Top gets the top element of the stack. And get min retrieves the minimum element in the stack. And they put a constraint. You must do the solution with O of 1 constant time for each function. So all of these should be constant time. The way that we're going to do this is it's actually pretty simple. We're going to be using a custom like data structure and just using a vector for that. And I think the most popular solution on LeetCode uses a linked list. I think that's unnecessarily complicated. I think using a stack is just fine. Sorry, a stack, like a class or a data structure, because the whole point of it is you need an extra field. So a regular vector, sorry, you can't store just an integer. You have to store a couple of items, the value itself and the minimum seen so far. And the reason that you wouldn't use something like a min heap or a priority queue is because those would lose the order of last in, first out that you want with a stack. And this works only for something like a minimum and maximum. So if you were to do like the median, that becomes a lot harder because the median could shift up or down depending on the value that you're putting in versus the minimum is always going to get smaller only. It can only get smaller on pushes and it can only get bigger on pops. So that simplifies things down, lets you remove that logarithmic um, component from your runtime. So let's go ahead and start writing it out. I can never remember like how to declare a struct super easily. I can remember if I need to do like type def or like write the object name after it. So I typically just go with classes just to remember one method and and stick to it and use it consistently because a class and a struct they're the same. You can literally give structs, constructors, and destructors, and you can get, it's a class. The only difference being with a class, things are private by default, and with a struct, things are public by default. So if you just declare it public, it doesn't matter. So I'm going to call it stack node. And then what does it need? It needs a value, int val, and it needs int um, I'm just gonna call it mn for min, and that way it won't. I don't want it to clash with the standard library min function, and that might be it. Let's call it public. Do I want to give it any sort of like custom constructors? It might be overkill. All right, so we have our stack, and it's gonna be a vector of stack nodes. And that's probably good. I don't know if I need to do anything in this here constructor yet. All right, so what do we do for val? We need to create a stack node. So stack node 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 dot val equals val. And then the tricky part here, not tricky, but node dot min equals the min of stack dot back dot mn versus the value being passed in. Let's see. And okay, what I'm actually going to do in this constructor is I'm going to put a dummy node first because I want this back call to never give an error. And that's okay because it doesn't specify that like the stack has to correspond to push operations, but we want something that's always going to lose this first like min comparison. So what I'm going to do is stack node. Um, the the value doesn't matter. I might just leave it unassigned because we never compare. We only care about like the current passed in value. So we never care about the value of the next thing on the stack. But for the sake of whatever, here I will assign it. So here's what I'm going to do: node.val, and I think LeetCode uses C++ 2023. Sorry, it uses 2017, which supports this very nice feature of multi-assignment. So node.min equals, we can have multiple equals on one line, and all of these are going to go assigned to whatever's most to the right. So it's going to be, I'm going to use a function called numeric limits that I think is worth memorizing. You pass it whatever data type. So in this case, integers, and that'll give you a namespace, and I can call like a max. So this will give me the max value possible in a 32-bit signed integer, which I think is in the 7 billions or so. So both of these are going to get that value. And the idea being we want it to basically be like infinity or something that's always going to lose in this min call. And then we're going to push it onto our stack. So stack.push back node. All right, so that's fine. And then here we're doing something kind of similar, and we got to push it onto our stack. So stack.push back node. All right, so we've got our creation of like the beginning of the stack, and then we've got our push call, which I think has everything we want. So node min equals the min of the last item on the, would it be the back? Yeah, so the back is the current top of the stack. Yeah, okay. Value passed in. All right, let's do pop. I think it's just stack.pop back. And that's good enough. All right, so top is going to return the value on the top of the stack. Stack dot back dot val. And then same for min, it's going to access the same thing. But instead of returning the value, it's going to return the min seen so far. So hopefully that works. Let's go ahead and run through an example. Well, first I'll talk about runtime and explain why each of these fits the criteria. All right, so we've got our stack item. It's got 2 integers associated with it. So creating one of these would be constant time. And here we're when we start up, we're creating one node, setting its values, and we're adding it to the stack, which this is constant. Adding things to like since vector guarantees contiguous memory, sometimes you do like it has to resize. It would be a linear copy, like a linear time copy to move everything to a new chunk of memory. But what it does is every time the vector needs to do that, it will double the amount of memory that it allocates for itself. So whether, if you've got 4 items and you want to add a 5th, it'll move to a space that has 8 slots available, and then your next like 3 or 4 pushback calls will not take extra memory because that memory is already allocated. And the result of that is when amortized, the expected worst case runtime to push things back onto the stack is still constant. It does that by doubling the amount of space. So if you were to do a lot of pushbacks, it would be like it would do a few sort of linear copies, but above certain sizes, like it'll just keep doubling and doubling the memory. So that's how that kind of works out under the hood. All right, so this push, we're creating a node, setting its 2 values. Min comparison, really like every operation, so assignment, min, like comparisons, that's all, it's linear on the number of bits. But since we're only dealing with 32-bit integers, That's constant because the number of bits is constant. So all these operations are constant. Push back, we talked about why that's constant. This is popping an item off the stack. That would also be constant. Um, returning values, that's constant. So every one of these functions is constant. Therefore, the time is constant and it's linear on the whole test case. And then same for the stack. Each entry is constant space because of these two values. And it's linear on the entire test case. If it's all pushes, then you'd have every item on the stack. So it's linear space. Let's go ahead and do an example. There's only one example, so let's run through it. All right, first we create our min stack. So what's gonna be on there? Yeah, I'm gonna represent it as tuples where the first item is the value and the second item is this min. So with our first one we created up, we're gonna have infinity and infinity. It's really like 7 billion. It's not actually infinity, but this is a lot shorter to write out. Okay, next call. We've got this push, which is gonna be -2. So what do we do on push? We have -2, we create a node, has a value of -2. And then I'll write that up here outside the stack because it's not there yet. And we set the minimum to the min of -2, whatever's on the top of the stack. So it's -2 versus infinity. So it's going to be -2. And then we put that on our stack. Function ends, and then this memory gets freed, but it was a copy constructor. So, sorry. Yeah, it was a copy constructor. So that's fine. We keep our value. Another push. This time it's 0. I'm going to write it in here instead. It's a little bit easier. All right, so we're setting our value to 0, but we're comparing -2 versus 0. So -2 is going to win. So our smallest seen so far is -2. Next, another push, so it's -3. In this case, we're setting it to -3 for the value, and then it's -3 versus -2. So -3 is going to win. All right, now we're past the pushes, and then we have this get min call. So let's go ahead and write out what the returns are. Get min is going to return. We're looking at the back of the stack. So top, yeah, back. So it's these. It's get min is going to return -3. And then pop. So we're just calling pop, pop back on the underlying vector itself. So that's gone. And then top. So on top, we're returning the value of the back of the stack. So that should be 0. That's good. And then, so pop, top, and then get min. So it's getting the min from the same one. So it should be -2 because the stack didn't change. And then that's the end of it. So then it would return all of those things. So on our expected output, it looks like it's got nulls for each of the things that return void. So I didn't write those down, but then we've got this -3 and then 0 and then -2. And that's what we wanted. So I think that'll about do it. Um, I did look at there's a solution that's got a lot of views and upvotes that uses a linked list. I think that's way unnecessarily complicated, and that gets into like, yeah, dynamically allocated memory, and yeah, I think this is much cleaner. Just make a custom object which got all the values you need, and then use already the standard library item that's meant specifically for stacks. So it's a vector. Giving it a run for syntax. Cool, accepted. And just to let you know, I did not do a practice run with this vector approach before filming this. I was originally practicing with the linked list, and then I thought, this is better. Yeah, so let's go ahead and submit. And mark it off. Thanks, guys.